Theoretical Recap. The OWASP Top 10 is a regularly updated reference document listing the 10 most critical web application security risks. It is not a checklist to mechanically tick off, but a risk map that helps teams prioritize where to focus their security efforts. Each entry represents a category of vulnerability, for example, a 0, 1, broken access control, a 0-2 cryptographic failures, a 0-3 injection, a 0-5 security misconfiguration, a 0-6 vulnerable and outdated components, etc., with associated attack scenarios and remediation guidance. A C/CD pipeline is a sequence of automated stages: source code management, Git, static analysis, SAST, dependency scanning, SCA, build, dynamic testing, DAST, containerization, and deployment. Each stage is an opportunity, or a failure point, relative to one or more OWASP categories. For example, a 0-6, vulnerable and outdated components, maps directly to SCA tooling in the pipeline, while a 0-3, injection, can be caught early by SAST rules during the commit or build phase. A common mistake is treating the OWASP Top 10 as a pure developer concern, ignoring the pipeline as a detection and enforcement layer. Another frequent error is mapping each risk to only one stage, when in reality most risks should be addressed at multiple points. Defense in depth. Keep this in mind. The pipeline is your automated security net, and the OWASP Top 10 tells you what that net must catch. Mini example. A developer commits code containing a raw SQL query. A SAST tool configured at the pre-commit or C stage flags it as a potential injection risk, A0-3, preventing it from reaching production. Without this mapping, the flaw might only be discovered during a manual pen test, or worse, in production after an incident. Workshop brief. Now that you have studied the OWASP Top 10 and have hands-on experience with Git security workflows, pre-commit hooks, and the concept of a minimal secure pipeline, as covered in the memo sheet and previous workshops, it is time to consolidate and apply this knowledge in a structured, analytical exercise. This workshop asks you to produce a mapping document that connects each of the OWASP Top 10 risk categories to the relevant stages of a C/CD pipeline, and to explain the detection or mitigation strategy applicable at each stage. Your goal is not to implement a full pipeline in this workshop. It is to demonstrate that you understand where in the delivery chain each category of vulnerability should be addressed, what type of tool or process is relevant, and why catching it there, rather than later, matters. This analytical skill is foundational for any DevSecOps role. Before you can secure a pipeline, you must be able to reason about it. Step 1. Set up your working document. Create a structured document, Markdown, spreadsheet, or any format you are comfortable with, that will serve as your mapping deliverable. Define a clear structure, columns or sections for the OWASP category, identifier and short name, the pipeline stages where it can be detected or mitigated, the type of tool or control applicable, SAST, DAST, SCA, secret scanning, policy enforcement, etc. A brief explanation of why this stage is appropriate, and at least one concrete example of a real tool or rule relevant to that pairing. Do not start filling in the content yet. Get the structure right first. Step 2. Map each OWASP Top 10 category to the pipeline. Work through all 10 OWASP categories systematically. For each one, identify which pipeline stages are most relevant and justify your choice. You are encouraged to assign multiple stages to a single category where it makes sense. Defense in depth. Think carefully about the difference between stages. A pre-commit hook runs locally before code is pushed. A CSAS scan runs on every pull request. SCA runs against the dependency manifest. DAST runs against a deployed instance. Be precise about which stage catches which type of signal. Avoid vague answers such as all stages. Be specific and justify your reasoning. This step requires genuine analytical effort and is the core of the workshop. Step 3. Identify the 2 highest priority mappings for your pipeline. Based on your mapping, select the 2 OWASP categories that you consider most critical to address early in the pipeline, i.e., as close to the developer as possible. Write a short justification, 5 to 10 sentences per category, explaining why early detection matters for that specific risk, what the cost of late detection would be, and what a realistic implementation of the control would look like in a team using Git and a basic C system, such as GitHub Actions or GitLab C. Draw on the pre-commit hook workshop and the secure branch policies chapter to ground your reasoning in what you have already built. Step 4. Identify gaps and propose improvements. No pipeline is perfect, especially at the beginner stage. Review your mapping and honestly identify at least 2 OWASP categories for which the pipeline coverage is weak or difficult to automate. For example, A04, insecure design is notoriously hard to catch with tooling alone. For each gap, propose a non-automated compensating control, a code review practice, a threat modeling session, a security training requirement, or a manual testing procedure. This step tests your ability to think beyond tooling and reason about security as a process, not just a set of scripts. Step 5. Finalize and submit your deliverable. Review your document for clarity, completeness, and consistency. Make sure every OWASP category is addressed, every mapping is justified, and your 2 priority sections and gap analysis are clearly identifiable. Export or save your document in a shareable format, PDF, Markdown file, or a shared spreadsheet link. Submit your solution before the deadline. Late submissions will not be reviewed in the scheduled feedback session. You have up to 3 days to complete and submit this workshop. This duration accounts for the research, reflection, and writing effort required to produce a thorough and well-reasoned deliverable. Do not treat it as a quick fill-in exercise. Budget at least 3 to 4 focused hours of work spread across the available time. You are fully authorized to consult all previous course materials, videos, quizzes, the memo sheet, workshop notes, the official OWASP website, tool documentation, blog posts, and any other internet resource you find relevant. You may discuss ideas with peers or seek help, but the final document must reflect your own analysis and be written in your own words. Copy-pasting from external sources without synthesis will result in a weak submission that does not demonstrate the expected analytical skills.